So it's important then for you, not just in creating prints or relaying information on prints with regards to tolerances, but reading prints. So here are the ways to communicate tolerance on a print. So this way here, just by way of review, this is how to use limit dimensioning when one dimension is written over top of another. Now, this tells you the largest a part can be and the smallest, and the larger dimension is written over top of the smaller. This is how you would use limit dimensioning with a leader and the dimensions placed on a line. So you're familiar with this. This is your leader, right? Your leader line. And here you notice these are limit dimensions on this side. Well, these are also limit dimensions, but notice the difference when you write limit dimensions on a line, not stacked, right? They're on a line. Then you put the smaller dimension first. Okay, all these little things are very important when it comes to interpreting engineering drawings. Okay, stacked limit dimensions, the larger on the top. Limit dimensions written on a line with a leader, the smaller dimension comes first because you're saying 1.4 to 1.25. When limit dimensions are used for a diameter, then you would put the diameter symbol. So when you're using limit dimensions on a line, just like we have up here with a leader, and there's a diameter, or you're pointing to a diameter, then you would put the diameter symbol. You only need one. You don't have to put a diameter symbol in front of each of these dimensions. You just put it in front of the one because it means the diameter can be from this size to this size, right? It refers to both dimensions. But again, notice it's the smaller dimension written before the larger dimension. And when we're using a radius call out, you know, when this leader's pointing to a radius, again, same thing, right? We have the R for radius will come before the numbers, and those numbers will be smallest to largest. It's important to just make sure that your diameter symbol or your radius symbol are in line with your dimensions. Don't have it up here somewhere, right? Put it right in line with your dimension. And these rules, it's not just for inch dimensioning. This applies, all of these rules apply to metric dimensioning as well. All right, so what about plus and minus tolerances? How do we communicate these? So the basic dimension is given first, and then the plus minus tolerance comes after. So here's an example of a bilateral plus minus tolerance. So try and get this in your head, the bilateral plus minus tolerance. The tolerance is the same whether it's plus or minus, okay? This is an example of an unequal bilateral plus minus tolerance. Again, notice that the plus tolerance is 7 thou, the minus is 2 thou. So it's still bilateral because your tolerance goes both directions, up and down, but they're not equal, right? So you would refer to this as your unequal bilateral tolerance. This is a unilateral plus minus tolerance. Unilateral plus minus tolerance is one that applies in one direction only. So you can see here that this 2.5 inch basic size has a plus 5 thou unilateral tolerance, because even though it shows a plus tolerance and then a minus tolerance here, notice that the minus is 0. So if you have a plus tolerance that says 0 or a minus tolerance that says 0, then that is a unilateral, one direction only, right? A unilateral tolerance.